Atoms are electrically neutral because the charges of the electron and the protons cancel each other out. However, a loss or gain of electrons form ions, and this is because electrons aren't as tightly held as protons and neutrons to the atom, which enables them to be lost, gained, or transferred. So there are two types: cations, which are positive, and these are ready to gain electrons, and anions, which are negatively charged, and they are ready to lose electrons, both in the pursuit of having a stable outer shell, just like the noble gases, of 8 electrons in the outer shell. So you see with the cations, you can have sodium ions, calcium ions, and aluminium ions. And with the anions, you can have, what do we have? Phosphorus, oxygen, and bromide. However, it has to be said that group 4 are not ionic, as they have no tendency to lose or gain electrons, as the energy transfer is too large to be favourable. So you can see that the cations are formed from groups 1 to 3, which are the metals, and the anions are formed from groups 5 to 7, which are the non-metals. We know group 4 doesn't do ionic bonding, but we can say that transitional elements do pretty much what they want. The different numbers of electrons in the d subshell means it can form stable ions with different charges, like Fe2+ and Fe3+, which is an ion of iron. Polyatomic ions are ions with more than one atom, which have a charge through the gain or loss of electrons. When you hear the owl noise, stop the video and dig out what you know of these regularly occurring polyatomic ions. If not, pause and learn them. The data booklet doesn't supply them, and you're expected to know them for IB questions. Ionic compounds form when oppositely charged ions attract and transfer electrons. So here we have lithium and bromine forming, well, I put lithium chloride, but it's supposed to be lithium bromide. But this can happen too, as they have the same charge. So what happens here is the lithium loses its outer electron and the chlorine atom gains it. And this produces a charged attraction between the two, called an electrostatic force, which pulls the two ions together. And you can label this an ionic bond, and we can say that compounds that show this characteristics are an ionic compound. Compound formulas are pretty easy. Just check out the periodic table and find the charges of the relevant atoms. So here we have potassium, which has a single charge as it's in group 1, which means it's a cation, positive charged, and bromide, which is a single negative charge as it's in group 7 and is an anion. Then write the charge above each ion. Now this is better illustrated in an ionic compound that has ions with more than one charge. So here we go. We have aluminium oxide here, aluminium having a 3+ charge and oxygen having 2 negative charge to get the Al2O3, which is the final formula compound. But it's simply demonstrated in potassium bromide, where it reaches an electrically stable ionic compound just on its own. And that's the final formula of those two. Putting polyatomic ions into ionic compounds isn't difficult either, you just have to bracket it. Just remember that working out the compound is simply balancing the positive and negative charges, taking into account each different charge, because this will affect the subscript, which is the number beneath every element. But how likely are these ions to form ionic compounds? Now this can be determined in two ways: the position of the elements in the periodic table and the difference in electronegativities. Here we have rubidium fluoride. Rubidium is near the bottom of group 1 and fluorine is at the top of group 7. And we learned in chapter 3 that the tendency to lose electrons and form positive ions increases down a group, whereas the tendency to gain electrons and form negative ions increases up a group. So the highest tendency to form ionic compounds will be between elements on the bottom left and those on the top right of the periodic table. And that is what rubidium fluoride does. But also, if the difference in electronegativities is greater than 1.8 on the Pauling scale, we know that the ionic compound is going to be predominantly ionic. The regular, predictable, three-dimensional crystalline structure is a trademark of ionic compounds, and more will be explored of this in later chapters and videos. Thank you for watching.